All right, good morning, everyone, and welcome to Keeping Up with Java. And when you think about it, it's actually quite a strange title, right? Because it used to be the other way around, where Java had to sort of keep up with us with these large releases every 3 or 4 years, and we were moving fast, we were agile, but Java was sort of lagging behind and then giving us these big bang releases every 3 or 4 years. And don't take me wrong, they were good releases, and we're still pretty happy with that, but they could do better. So things have definitely changed in the past few years. So at the moment, we're already on Java 13. Maybe not everyone here, so let's do a quick poll. Who's currently developing on a Java version 7 or earlier? No hands. Well done. Nice. Who's currently developing on Java 8? Right. That's what I thought. Yeah. You're being sidelined by Big Bang, people. Let us sink in. So, and who's currently developing on a newer version of Java than Java 8? Very good. So, quite a few hands. And it is actually something that we see in the industry, right? So, we do have an issue with people sticking to Java 8 just because it's familiar, it's nice. But we're going to change that today because I want to show you all the highlights of everything that happened with Java since Java 9 was released, which is already 2 years ago. So hopefully this will be useful to you, and this will also give you some food for thought in terms of why am I still on Java 8 and what does it take to get to the next level. So my name is Sander Mak. I've been in the Java space for over a decade, also following quite closely along with what's happening in the JDK and in Java development itself. And have been active as a consultant for many, many years. Recently joined the tech leadership team at Picnic, an online grocery startup, which is also doing some pretty amazing stuff using Java mainly. But that's not this talk. Happy to talk about that later, but we're going to focus on Java itself today. And during my consultancy days, but also now, I truly believe that doing modular software development in whatever shape or form that takes is really the key for us to create maintainable and extensible systems. And it's probably no surprise that when I learned that Java would also get a module system, this is something I dove into quite early and quite deeply, which also led to the opportunity to write this book together with Paul Bakker for O'Reilly on this Java module system. And we'll talk a bit about that as well, because this is a major shift in Java itself. But obviously, there's much, much more than that. So I like to share the things I learn when I watch Java closely, either at sites like Pluralsight, where I have quite a few content, but also at conferences, especially JFall. I love JFall. It's actually the conference where I don't have to travel that much. I can go by bike. I'm pretty happy about that. Until today, that is, because, well, like my fingers froze off this morning, and I thought, well, crap, I have to do some live coding. But fortunately, I had some time to defrost, let's say, so I think we'll be fine. But anyway, let's get started, because we're here for the highlights in what happened in Java, right? So how shall we do this? I could, of course, just start all the way at the beginning with Java 9, which is already 2 years ago, which apparently you people missed, most of you at least, but it would be a bit boring, I think. So let's do this back to the future style. So we're going to start where we're now at Java 13. And we're going to talk a little bit about that, and then work our way backwards in terms of features of what happened in the intermediate releases until we're at Java 9, which was a pretty big release, so we'll spend some time on that as well. It was actually one of the last big releases of Java, so much important stuff in there too. So we're going to do this like this. This means that we're starting with Java 13, which was released in September of this year, actually previous month. So this is all pretty fresh and pretty new. I don't think lots of people are currently already using this. But that makes it even more exciting to have a look at what's in there. So in terms of features, what is most striking is something called text blocks. And this has everything to do with multi-line strings in Java source code. So if you look at this, this might be a typical piece of JSON you have in your test code to assert later, something like that. But is this actually JSON? It's pretty hard to tell, right? Because of all the concatenation that we're doing to making it multi-line, because of all the escaping that you have to do with the double quotes, you have to add the /n new lines yourself to make sure that it's indented properly in the end in the string. So all in all, it works, but it's definitely not nice. So what is nice? Well, I think the preview feature they added to the Java language in Java 13 is actually pretty nice. And this is a text block. So what you're seeing here is a block that you open with 3 double quotes and a new line. This new line is also mandatory. And then you can just start typing any kind of multi-line string that you want. And you can add some indentation. You can use double quotes without escaping. The new lines that you have there in the source code will also end up in this string literal, because in the end, the text block will just become a string. There's no magic new type or anything. It will just be a string, but it's much easier to type this in source code this way. And the interesting thing here is that the indentation, some of it will be preserved and some of it will be stripped. And it actually does a pretty good job at doing what you would expect, because the indentation that's before the curly braces, so everything that you do to align your source code, will be ignored. But the indentation in the JSON block itself, before the key value pairs, that will be preserved. So that's a really, really nice way of working with multi-line strings in Java. However, in Java 13, if you download it, it's not there by default. It is a preview feature, which is also kind of a new thing in Java. We didn't used to have this, right? I'll show you how to use preview features in a bit, because this is not the only preview feature, there are more. But they actually did this to get more feedback on new features, on proposed new features, because we have this new release schedule. Every 6 months we're getting a release, which means that the features that are put in there are a bit smaller. There's also a quicker cycle. Less people are inclined to download early access builds and try those out. So they said, well, we're just going to add these features in preview to the language itself. So if you download the regular JDK, you can already use these new features without them being final yet. You can play with them. Probably not very wise to use them production code yet, but you can already try it out and give feedback. So this is one of those features, and I expect this to be finalized in a not too distant future, because this feature is actually pretty straightforward and very, very helpful. Now, talking about preview features, let's take a step back to Java 12, which of course is before Java 13. This one was released in March of this year. So already a little bit older, and in there they actually addressed this issue. Because I think we've all seen this kind of code, right? With the switch statement, where you wanted to assign certain value to a variable based on an enum, maybe in this case. And the way you have to write this, I mean, this works again, but it's far from nice. You have this awkward stacked syntax of cases that belong together, and the colons after that. Then after Sunday here, we're doing an assignment, after which you don't have to, shouldn't forget the break, right? Because if you do, and you've probably all encountered this, then it just falls through and executes all the other cases as well. Why? Well, because C did that. Well, is that a good reason? Well, I don't think so, and nowadays in 2019, but then it seemed like a good idea. So all in all, this works, but it's really not nice. So they also introduced another preview feature in Java 12, which is still a preview feature in Java 13, called switch expressions. So what is a switch expression? Well, this turns the switch statement, which just executes statements, into an expression that returns a value. So what we see here is that we can assign the switch directly to the variable that we want to initialize. And then, rather than having this awkward stacked case syntax with the colons, we can do nice comma-separated cases for the cases that belong together. And the real difference here is that we don't have a colon and then several statements and then you have to do break. No, we actually can use a new syntax with the arrow, and right after the arrow we can provide an expression. And this expression will be the resulting value that is assigned to this variable if that case matches. So this is actually something that makes the pattern that we saw in the previous slide much more concise, and also turns the switch into an expression. Mind you, this is not something that replaces the switch statement, so the switch statement will still be there. It's just an additional way of using switch, which oftentimes is much more concise and much more useful. So let's have a look at how you can actually use this in practice when you download, in this case, Java 12 or 13. So what I have here is a old school switch statement, where we have a day of the week enum, and we switch on it, and on Saturday and Sunday we relax, on Monday we try to work, and for the rest of the week we actually do work. So I want to change this into a switch expression. I'm going to refactor that. We can do this easily by just removing the intermediate variable declaration and assigning the result of the switch directly. And what we can also do is we can combine these cases, right? as we saw, with commas on a single line, which is much nicer. And then instead of multiple statements and doing the assignment, we can actually use the arrow and just have the relax value be returned if Saturday or Sunday match. And we can do the same for Monday, where we replace the arrow again. We can remove the break because we don't have to tell it that it has to return. It's already implied in the arrow. And we still have the default, which also works. And we can use the arrow there to say work. Now, we're almost done, because if I would compile this, it wouldn't actually compile, because we now have an assignment statement that is not terminated by a semicolon. And we know all statements in Java should be terminated by a semicolon. So I still need to add the semicolon here, and we're done. So this sort of makes this nicer to read. But still, we need to compile this. So let's first check that we have the right Java version here. Yes, I'm on 13. That should work. And I'm going to say compile this. So let's compile main.java. And interestingly, it says, OK, well, I sort of understand this, but did you actually really mean to use this preview feature? Because it's not final yet. And if you do, then use this enable preview flag. So let's do that. I'm going to add the enable preview flag. I'm going to compile main.java. And then it still says, OK, but wait, at which language level do you want to enable the preview features? So in this case, it's pretty straightforward. And on Java 13, I want to enable the preview features of Java 13, single dash. There we go. Or yes, let's use the new release flag, which is also possible. There we go. Now it compiles, and it does give us a note, because, well, we shouldn't be using this in production code. So it says, OK, it uses preview features, be aware. And if we try to run this code, then we also get an error. Why is that? Well, that's to prevent us from just pulling in some library which maybe accidentally uses preview features, depending on that, without knowing that we depend on preview features. So in the bytecode execution, it's also checked whether you want to enable preview features. And in this case, we want to do enable preview, so we can do this on the JVM level as well. Here we don't have to provide the source level because it's already encoded in the class file, which level it is. And this now runs and gives us back the value that we would expect for Saturday. So that's good. So keep in mind, if you download new JDKs, they might have preview features, but you have to opt in to use them and to try them out, which is good. I would also encourage you to do that, also to give feedback on mailing lists, etc., because they actually listen to feedback from real developers like us. And this is a great way to get familiar with the future of Java. All right, that was a demo. Which brings us to Java 11. And Java 11 was sort of a pivotal release in terms of long-term support. We'll talk a little bit about that towards the end of this talk. But I want to talk about a different feature that was added in Java 11 first. So one of the big things that was added is actually a replacement for the very, very old HTTP URL connection API that we had in Java. Who here has used that API, right? Yeah, I feel sorry for you, because it's a really old and crafty API. Why? Not because they wanted to, but it was created in Java 1.1, so there were no enums, no generics, no lambdas, nothing, basically. So it's a pretty horrible API. So what they did is they created a completely new one called HttpClient, and it's not just a replacement of what HTTP URL connection could do. It's actually much, much better, and it supports modern technologies like HTTP2, WebSocket communication, even integration with reactive streams, which are also part of the JDK since Java 9. So all in all, a very, very nice addition. If you look at it and if you start using it, you'll see that it's very much inspired by things like Apache HTTpClient and OKHTTP and these kind of APIs. So it's really great to have this in the standard library, finally. So not having to depend on these external libraries and frameworks. So what does it look like? Well, there are three important types that you need to know about when you start using HttpClient. The first of which is, hopefully not too surprising, HttpClient itself. And on HttpClient, there are two most important methods called send and send async. The first one, send, is for doing blocking and synchronous calls to HTTP servers. The second one, obviously, does asynchronous and non-blocking calls and gives you back a completable future, a type that was introduced in Java 8 to work with in an asynchronous fashion. Now, of course, it's interesting, how do you get an HttpClient? Well, you can't instantiate it directly, because most of the types in the HttpClient API are immutable. and are by that virtue also thread safe and can be easily shared. So we have to use a builder API to create an HttpClient instance. And this holds for most of the types in the HttpClient API. You use a builder to create them. Once you call build, you get back an immutable and thread-safe object that you can freely share across your application and reuse whenever you want. So if you're going to use send, you will need to create an HTTP request object. Again, hopefully no surprises there. And it has everything that you would expect. So in the URI, it has the headers, it has the method of the HTTP call, so is it get, put, post, delete, etc. And more like that. And again, you don't instantiate this directly. You use the builder API that comes with the HTTP request to make sure that you get an immutable and thread-safe HTTP request to share in your application, to use in your application. So where there's a request, hopefully there's also a response, which comes back as an HTTP response type here. And again, this has everything you would expect. So the HTTP status code, is it 200 OK, 500 server error, things like that. And obviously, we're most interested in the body, so this is also part of the HTTP response. And if you start using this API, this is the most simple way to get started. So you can call HttpClient.new HttpClient, so we're even bypassing the whole builder stuff here. We just get a client with all default settings, which are pretty okay to work with. And once we have the client, we start creating our requests. Here we do use the builder API. So this builder API is invoked with new builder. We pass in a URI. We're going to call Google in this case, and Google supports HTTP2. And by default, the HTTP client will try an HTTP2 call. If that doesn't work, it will fall back to HTTP 1.1, in the default configuration at least. Then we say it's a GET request. We could even omit this because GET is the default, but I think it's okay to be a little bit clearer here and to be precise in what you mean. And then we call build and we get back our request that we can then use in the send method. Because in the last line, you can see here that I'm calling the synchronous send method on HTTP client. I'm passing in our request. And the second parameter there we haven't talked about yet, but I'm also passing in a so-called body handler. And a body handler is actually responsible for turning the raw response bytes of the server into a Java object. Now, you could write your own body handlers, and there's no hindrance there to do that. But what you actually want to do is use some of the predefined body handlers, which live in the body handlers class. So here I'm calling body handlers off string, which gives me back a body handler that turns the raw response bytes of the server into a Java string with some default character set. And by doing this, I get back an HTTP response, which wraps the body. In this case, that's a string, so you see the back in the generic type as well. So we get an HTTP response of string, which we can use. And this will only return after the server has given back a response. If I use send async, I will immediately get back a completable future, wrapping this HTTP response, which will at some point in time in the future be completed. And then I can configure callbacks and work with that asynchronously. So these are the two modes of operations of HTTP client. All right. So that was Java 13, 12, 11. So what's next? 10? Well, I think we have a little rip in our time-space continuum because I want to show a couple of features of Java 9 first before we go to Java 10. And it will become clear why that is in a bit. So the one thing I want to show with Java 9 is actually not a language feature, but it is a new tool that was added to the JDK. And it's called JShell. And JShell is a REPL. So who knows what JShell what REPL stands for? Anyone? Just shout it out. Read, yeah. Eval, print, loop. Exactly. So a few people knew this, but if you don't know this acronym, it probably doesn't mean anything still. So what this is, JShell is an interactive console application where you can type in some Java code, where you can hit enter. It will run this code for you. And of course, this code might result in some output. And this will be printed to the console, so you can inspect it. And you can do this iteratively and incrementally. So it's a tool to do interactive coding and interactive exploration of APIs and things like that. So languages like Scala and Groovy already had this for quite a while. It even started with Lisp, of course, many decades ago. But now we finally have a REPL that is pure Java as well. So I won't spend any more words without showing this. So I'm going to switch over to my shell here. I'm going to start JShell. There we go. And the first thing I'm going to teach you is how to get out, because we all had the Vim experience, right? Where you start something and you're like, how do we get out? So we can do /exit, and then we're out again. Control-C won't work, Control-D will work to break out, so you can do that as well. But we don't want to get out, we want to get in, and I want to have JShell. And JShell allows me essentially to do 3 things. So first of all, I can type in and evaluate Java expressions. I can type in and evaluate Java statements, and I can create new definitions, so new methods, new classes, and things like that. So a quick example here, it's the simplest expression possible, of course, 1 + 1, which is fortunately still 2. But as you can see, before the 2, we have this $1, and this $1 is a generated or synthetic variable name that we can use to refer back to what we did previously. So I can do $1 + 2, which equals to 2 + 2, which is 4. That's good. We can also, if we want to, just give names to variables. Of course, this is now a statement rather than an expression, what I'm doing here. So we get back a named variable in this case. That also works. But besides expressions, we can also do statements. So let's do a simple one, system out, println, there we go. Hello, JFol. And it just prints it out, and there's no generated variable name because it's a void method, so there's no return value. It does print our text. Anyone see anything different with regular Java code here? There's no semicolon. Woo! Yeah, so if you have a single line statement in JShell, you can just omit the semicolon if you want to. So that's nice to know. So this works, but what about the interactivity and the exploration? So if I were to just type systemout.pr and hit tab, I actually get some nice tab completion, so it completes to the longest prefix. It gives me all the other options. So in this case, I'm interested in println, for example. I open the parentheses, I hit tab, I get all the overloads, so I see what's actually possible. It tells me, press tab again to see documentation. That's nice. So I hit tab again, and I get the Java doc right here in my console. So this is a very interesting and a nice way to explore APIs, but directly execute them as well, and also be able to read their documentation if you want to. Now, by default, JShell starts with all the JDK stuff on the class path. You can add your own jars, so you can set your own class path to explore third-party code. IntelliJ even has a mode where you can open a JShell where your current project's class path will be the class path of JShell, so you can just explore anything that you have in your current project, which is all very nice and works pretty well. So I think this is a great way to do exploration in APIs and to do just try things out, where you previously might just write a class and compile it and run it, or maybe write a unit test to try some things out. This is a pretty interesting way to do more like that. You can also try out some of the new JDK APIs. For example, did you know that they added a repeat method to string? I didn't, but I found out using JShell. And then you can do stuff like this in a single line, which is pretty nice. So just open this up if you have a new JDK and start exploring some of the types that are in there, because you might be pretty surprised by what new methods are available and what new APIs are available. So there is a third thing that we didn't do yet. So we did expressions, statements, but you can also do definitions. So I want to show you that you can do a simple method definition as well within JShell. So let's create a method ×2. I open the curly brace. It sees that there's multi-line input. I'm not done yet. So I can return. I could do I ×2, but I want to do something different. I want to do internal ×2, which is a method that we haven't defined yet. But we can do this. And JShell actually allows this. So we can do both top-down and bottom-up development. So we don't have to do everything in the right order. Now it says I created this method, but you cannot invoke it until you have an internal ×2 method. So let's create that, internal ×2. There we go. And open it again. Let's return I ×2, just to be good. And we created this, and now we can call ×2. And we can call it with 2, and we get back 4, which is nice. But the really interesting thing is that if I go back, and there's history in my console, which is very helpful, and I change this definition to I ×3, there we go. It says modify the method. And then I call ×2, and I actually can do tab completion on that too, because it knows everything that's defined in our current scope. And I call it with 2. It now doesn't give back 4, but it gives back 6. So there's a very dynamic binding going on here, which makes experimentation and tweaking and just doing things incrementally pretty easy. So again, not a tool that you will use every day, but every once in a while I fire it up to try something out, maybe with stream pipelines or with Java regular expressions, because they're always a little bit different than all the other regular expression engines that you have online. So now you can finally just do it in Java code with Java APIs, just as it would execute in regular code. So the other small thing they added, but very useful in Java 9, are the collection factory methods. So looking at this code, I mean, it works. We create a collection. We need to think about what kind of collection we want. Well, 99% of the time people just pick array list because everyone else does. So let's do that and do book add, and then 4 statements later we have a collection with some predefined elements in there. We can do better, right? So I know there's arrays.asList, but I mean, really? Using an arrays class to get a list? And again, that's only for lists and not for sets and other kinds of maps and kinds of collections. So that's not really a solution. So what they did in Java 9 is they didn't add new syntax for collection literals. No, they just added factory methods to, in this case, the list interface, where you can say list off and just pass in the elements that you want to have in there, and you get back an immutable list containing these elements that you can use directly. And you don't have to worry about the type. It will pick an optimal one for you based on the number of elements that you put in there. And this not only works for lists, but it also works for sets and for maps, whereby maps you have to provide key value, key value, key value, instead of just the values, of course. But this is a very minor, but very useful addition. I've used this in lots of code already, where you often have, either in tests, but also in production code, some predefined set of literals in a collection. And I would really urge you to start looking into this and use this as well. Now we can finally have a look at Java 10. So what happened in Java 10? Well, like in all the other releases, it wasn't a very big release, but they still managed to put a language change in there. So Java 10 offered us var, the famous, or should I say infamous, feature that's also known as local variable type inference. So what is this about? It's about variables, but not just any variables. It should be a local variable that we're talking about. And what var allows us to do is it allows us to omit the exact type, string in this case, and replace it with var. And people are like, is Java JavaScript now? This is not why I became a backend developer, right? I try to avoid this crap. No, fortunately, it's not a dynamically typed thing. There's still a static type. The type of name is still string. It's just that we asked the compiler to infer it for us, rather than us having to type it out explicitly. So, next question, of course, is should you just go around and just replace all local variable types with var, because that seems easy, right? Well, I would be cautious about that too, because even though it seems a fairly simple and innocent feature, it is not always a given that it's an improvement to use var. And we'll see why later. But if you have code like this, where you see URL, URL is new URL, this is sort of repetitive, right? And the same for buffered input stream is new buffered input stream. Probably lots of people have been thinking this is quite redundant, and it is. So if you were to use var in these situations, it would sort of look like this. And something interesting happens when you start using var in these kinds of pieces of code. Because rather than the focus being on the types, the focus shifts to the names of the variables, which also puts the burden on us as developers to come up with good variable names, which is always hard, but well, that's what we get paid for, right? But I think in this case, it's really an improvement. It really helps us to read this code better, and it's perfectly clear what the type of the book URL variable is, because, well, the constructor invocation is right there on the right-hand side. And the same holds for the buffered input stream constructor invocation. So it's perfectly clear what's happening there. You might wonder about the connection because, well, we're calling a method and we don't exactly know what type it gives back. But in this case, you could also argue we're not really interested in the type, we're just interested in passing it along and using it. So I think this is a fine example of where code does improve when using var. However, like I said, don't just go around and replace everything with var, because if you do, you might run into some interesting issues. And for that, I want to switch back to our favorite new tool, JShell. And I'm going to ask it to give us a little bit more feedback about what we're doing, like this. And I'm going to use you, dear audience, as my compilers. That's right. So I'm going to do several statements and declarations of variables. And we'll start very easy. Var I is 1. What will be the type of I? Anyone? Int, yes. That was a no-brainer, right? So it says, OK, I create the variable with type int. That's good. Now, what about if I were to do var d is 2.0? You've probably, hopefully, all did your certifications, so you should know this. What is it? Double? Some floats? Yeah, it's already getting a little bit dicey. But yeah, indeed, it's a double. So you could be more explicit, like use the correct literal and do it this way. It's even more clear that it's a double this way. So still, this is pretty OK. What about this one? What's the type here? Yeah, this is going to get harder and harder. I'm already warning you. So I hear objects. I hear exception. I hear somebody saying void. And there's actually a void type in the JDK with an uppercase V that would fit this description. That will be a valid type here, but it will be a pretty useless variable because you can only assign nulls. So in this case, it's indeed a compiler error. So they said, well, this is so useless. We could infer object, we could infer void, but let's not just do this. Let's be explicit if you want to do this. Well, we can be explicit. We can trick the system here and say, OK, we'll add a cast, and there's enough information now. So this actually works, but I would not recommend doing this. If you're doing this, just drop the var and put object as a type there, right? That will be the best way to go forward. But what about if we're going to lists? And we're going to use this fancy new list of feature. And we're going to put a 1 integer, a 2.0 double, and a string in there. What would be the type of this? Or would it be an error, or what do you think? A list of objects. That might work, yeah? Any other guesses? Error? I hear some people saying error. Yeah? Let's have a look. Wow! Isn't that a beauty, right? So what we see here is that the compiler is getting a little bit too smart for its own good, because it tries to find the most precise type that fits all the elements in this list that we're providing here. And actually, they all implement serializable, they all implement comparable, they all implement something called constable and whatever. This is, of course, a type that we could have never expressed ourselves in source code, which is pretty interesting if this is now the actual type of the variable that's being inferred. I hope your junior developer doesn't run into this piece of code and be worrying about, OK, why can't I add this to this list? Because, well, you get the picture, right? This is pretty strange behavior. So if you want this to be a list of objects, just say so, rather than leaving it up to the var feature. So one more. Let's say if we are going to create an array list directly, and we're going to use this fancy new feature introduced way back when in Java 7 called the diamond operator. So what happens here? What's the type? Or will this also be an error, or what do you think? Error, OK. I hear no types being shouted, which seems reasonable, right? Because, well, what are you going to do? There's just not enough information to derive the generic type here. Ha! Big surprise. Now you do get an array list of objects. So again, a very innocent, small feature, but be very careful about using it. I'm not saying it's a bad feature. It's just something that takes a bit of discipline and a bit of insight into when to use it. So, like I said, with the pieces of code, with the constructor invocations, it can really clean up. It can really help. But in other situations, it's not actually that clear what the type is. And most of the time, it will be better to err on the side of caution there and not use var. So there's a style guide put out by the JDK team. If you Google for that, var style guide, you'll find that, which is pretty good. So if you're going to use this feature, at least read that. Which brings us back by Java 9. Because like I said, Java 9 is a really big release. And the things that we saw so far, JShell and the collection factor methods were nice. But one of the really big things in there is the module system. And of course, I already said, I'm pretty interested in modular development myself, so we're going to look into this big shift a bit as well. And this does not just affect code if you want to use modules, it also affects your code if you're not going to use modules and you're going to a newer version of Java. So it's interesting to know about the functionality of the module system nevertheless. So first question is, what is a module actually? And if you think about it, it's actually the next logical step up in terms of abstraction, if you think about what's happening in Java. So we have methods that are being grouped by classes, and classes are being grouped into packages, and now packages can be grouped into modules. And you can create a module, and you can view a module as just a regular jar file with some additional information. And this additional information lives in a module declaration. Here we see a very simple module declaration. It's as simple as possible. It has the module keyword, and it has the name of the module, called main. And the empty body, well, we'll leave it as is for now, but we'll see that we need to add some more later. And this actually results in a jar file that might contain several packages, main web, persistence, integration, whatever, doesn't really matter, which is now known as the module with the name main. And we can refer to this from other modules by this name, and it has an identity, which is a pretty big change over jar files, because jar files are just dumb zip files, and the platform doesn't really know anything about jar files, it just cares about the classes that are in there. Now we have something that actually represents the grouping of packages that together make up a module. But if you're doing modular development and you end up with an application with one module, well, you're doing it wrong. Because modular development is all about chopping up your application into small pieces. But then again, you want these pieces to come back together and to be assembled into a functioning and running application, and hopefully in a little bit of a reliable way, without relying on luck too much. And that's something that you could do with dependencies between modules. So here we can see that module main now expresses a dependency on module helper, because apparently module main needs some code that lives in module helper. We can express this using requires helper. Now, of course, it's nothing new that jar files need other jar files to do their work. We have this in our applications every day. What is new is that we can actually instruct the Java compiler and the Java runtime to know about these relations, because up until now, with our class path, we just dump a load of jar files on there and then start the application and pray that it works, right? Because if there's a missing jar file, and if you have a class path issue, it will blow up at runtime at some point where a class is loaded and the JVM can't find it. It will just throw up its hands and say, well, can't go on, the class is not there. Or there's maybe a conflict because you have multiple versions of a jar file. So the class path is very brittle, and I think we've all lived in class path hell at some point in time in our careers. So with having these dependencies explicit between modules, the JVM and the runtime can actually use this information as well, because this module info.java that we see here gets compiled into a class file, which is carried over to runtime. And now if we would start our application with only the main module available on the module path, and I'll talk a little bit about what the module path is later, but it's sort of the successor of the class path, then it won't even load a single line of code of this main module. It will just say, well, I see that you have this main module, and it requires the helper module, but the helper module isn't there, so please go fix this first before you even start this application of yours, right? So there's no risks of runtime errors that you only find out at some point in time when a class is lazily loaded anymore, which is good. The other side of the coin is that modules also help us do access control, similar to how you have private and public methods on the class, and how you can have package private types inside of a package. We can also, at the package level, decide which packages of a module are public API. And public API means, what do I offer to the outside world? If I have a dependency from module main to module helper, it can only use the types that are exported this way, using the exports keyword. And of course, if you export a package, if you make it API, it's also sort of a contract or a promise that you will evolve this API, hopefully in a backward compatible manner. So this is something that you should think really hard about when you create a module. What is actually public and what is my private internal implementation details? Because the flip side of the coin is that besides exposing these well-defined interfaces to the outside world, the rest, everything else that's inside of a module is strongly encapsulated. And strong encapsulation here means that you will not be able to code against any types that are in these encapsulated packages. You cannot even access them using reflection at runtime. So we won't go too deep into that, because of course there are lots of reflection-based frameworks, and there are some modes of operations where these can still function without breaking encapsulation. But in effect, you should think about a module as being divided into two parts, a public and exported part, and a strongly encapsulated part. And strong encapsulation, hiding stuff, we know that this helps us to do large-scale development, to do protection of parts that other people shouldn't depend on, so that we can easily refactor it, we easily can maintain it without breaking any of our consumers, because the consumers only know about our exposed API. All right, that's a lot of talking, so let's show a little bit of what this looks like in practice. I have a simple 2-module application here, and why is it a modular application? Well, that's because there are module info.java files here. So I have a CLI module, I have a analysis module where some text analysis is done, and this is just plain Java. There's no frameworks, no annotations, but inside of this module info.java, I can give dependencies on other modules. So I see that this CLI module depends on the analysis module, and I can see in the analysis module that we export this package, because otherwise the CLI module would not be able to access this FlashKK type, even though it's a public class, right? So it's a pretty big change in terms of access control. So now I can compile this using a new flag called module source path, which understands having multiple modules in the source folder. You don't have to use this, but you can. And I'm going to compile all files, giving me, focus in the right window, there, giving me the output where we have these 2 compiled modules now. And you can see that the module info is preserved and is also available at runtime. So if I'm going to run this using the module path, there we go. I'm going to set it to the out directory. I'm going to run the easytext.analysis, no, CLI module, of course. I want to start the CLI module. Because I haven't packaged it into a jar file yet, and giving a main entry class point, I need to provide this here. So I'm going to say, I'm going to start the main method from this module. There we go. And Java modulator, easytext, what did I do wrong? This is interesting. Java modulator, easytext, CLI. It seems to be there. And I don't see any obvious typos. Well, anyway, let's skip this. This is interesting, something to debug later. But what would happen here is that it would start loading this module, and it would also find the other module on the module path. And if I were to remove this analysis module, it actually tells me upfront that there's an error while running the application, while setting up the module graph, because it cannot find this analysis module, which is the scenario that we talked about previously. So quickly, why was this added to the JDK as a feature? Well, obviously so that we could use it, but there's a more selfish reason for why this was added, because the JDK itself is the sort of the ultimate monolith. There's lots of stuff in there, became pretty hard to evolve and to maintain, especially because lots of people started depending on the internal details of the JDK, and it was very hard to change or remove stuff. So having these modules, having these explicit dependencies, but moreover having strong encapsulation of the internals of the JDK itself will allow the JDK to evolve over the next 20 years of Java, rather than just evolving like this big ball of tens of thousands of classes which live in the rt.jar file in your Java 8 installation, and have something that's more reliable and future-proof. And of course, this doesn't just hold for the JDK. We all have large-scale code bases where this question of structure and dependencies and encapsulation is at play. And if you only depend on developer discipline and having good people and working in the right way, it might go well for a while, but we all know teams change, architects change, and you actually want to translate these whiteboard designs that you have not into just information in people's heads, but you also want to encode this in tooling around it. And the module system is one way to do this. So it doesn't just, the module system doesn't just make things possible that were already possible but harder to do. It also makes some things possible that weren't possible before. And one of these things is in a tool called JLink. And JLink aims at solving the distribution issue of Java applications. So what you see there is that normally you have your JDK, you have your application on top of that, and usually you don't use everything that's in the JDK. If you have a web application, you don't need Swing, you don't need AWT, but it's all still there. So what JLink does is, if you have a modular application, it allows you to create a so-called custom runtime image containing just your application modules and your dependencies, and only these parts of the JDK, these modules of the JDK that your application really needs. How does it know this? Well, because we created these module declarations with all these explicit dependencies. And this can be a pretty small one if you're just depending on Java base in this example, like in my CLI code that I had previously, where you can get pretty small images. So when is this useful? Well, if you're in the cloud world, for example, and shipping around Docker images, it makes sense to make them as small as possible. Also, if you're in the IoT space, for example, it really helps to preserve your resources. So in this case, it's a very nice tool to look at if you're going the modular way. But like I said, if you're going to a newer version of Java, you don't have to use modules. It's completely optional. But there's still some impact from the fact that the JDK itself has been modularized if you're moving to this newer version of Java. So if you have a class path-based application and you want to run it on a newer version of Java and you compile it on Java 8, there's one issue that you can run into, and that's the fact that your code, or maybe the dependencies that you use, are depending and using these internal implementation details that now have been encapsulated. So fortunately, if you're running on the class path in Java 11 and later, there's still sort of a lenient phase where this is allowed, but it will print a warning from JDK saying, okay, you shouldn't actually depend on these APIs. So that's something to address, but it will still run. However, if you want to compile code on the newer versions of Java that make use of these internal APIs, then it will just be a hard error. It won't compile. So you will have to migrate away from these internal APIs to public and supported APIs, which in the end is a good thing, but it might definitely be something that needs attention in your code base. The other thing is that some enterprise APIs have been removed. So things like JAX-B, JAX-WS, things that shouldn't have been in Java SE in the first place, they were put into their own modules in Java 9 with the names that you can see there. And they were immediately deprecated in Java 9, and they have been removed in Java 11. So these are now effectively gone. So what to make of this, right? Because most of you are still currently on Java 8. And you're not alone, so there are lots of polls where people indicate that around 80% of the community, this was last year, but it changes a little bit, but not that much yet, are still on Java 8. So I think Java 11 is a pretty important turning point here. So we do have this 6 monthly schedule, and for some teams it might be feasible to jump on this release train. For others, maybe not so. And in that case, Java 11 is the version that has been appointed by Oracle as long-term support. This does require, if you want to make use of this long-term support, that you use Oracle JDK, which is paid as of Java 11, which is a big change. But there are other vendors as well, as we will see, who also have pledged to offer support, either paid or for free, on Java 11. If you're going to go down the LTS route, this means you would upgrade every 3 years, which is also not ideal, right? Because we have lots of in-between versions with all these new features that we talked about that you miss. There might be even deprecations and removals of APIs. So this is definitely food for thought to take back with you. And how are you going to approach this? Are you as agile as you say you are? Are you able to upgrade Java every 6 months and push your Docker containers to the cloud? Or are you in a situation where there's lots of people to convince, ops departments to go out into updating, making it harder and slower? Then the LTS route might be better. But in any case, JDK 11 changes the game. Like I said, it becomes a paid option. But the good thing is that Oracle has committed to make OpenJDK and Oracle JDK feature-for-feature equivalent. And they did this by open sourcing some commercial features, removing some others. So in the end, there's no functional or performance difference anymore between OpenJDK and Oracle JDK as of Java 11, which is very good because this allows us choice. Right? So if you're currently on Oracle JDK 8, you could go the route of migrating to Oracle JDK 11, the LTS one, and paying them a subscription fee, which is completely reasonable and a pretty good choice for lots of people. But you can also go down the OpenJDK route, where you say, okay, I'm moving away from Oracle JDK 8, and now I'm going to a OpenJDK distribution. And these are feature-for-feature equivalent. So there's no reason to prefer Oracle JDK anymore, because it's better or faster or more feature-complete, which was the case in Java 8 and earlier. And the interesting thing is that there are lots of vendors who have pledged to give support, either for free or paid, on OpenJDK 11 as well. And which one do you pick? Well, there's no one-size-fits-all answer here. It's really context-dependent. So on the one hand, if you're pushing to Amazon using their AMIs, etc., it's pretty easy to integrate that with Amazon Corretto JDK 11. If you're on Red Hat Enterprise Linux, well, it makes total sense to use their JDK, which they support in that environment, etc. So this is already pretty new for us, because by default, like we saw, most people just used to pick Oracle JDK and be done with it. I think having choice is good, but I can also understand a little bit of hesitance and confusion around having so many choices. It's a little bit of the Linux model, right? Where we have one Linux kernel, but lots of distributions which add their own form of support and flavor to it. So that's something to definitely think about. So that's it for me. I want to leave you with a few messages, because we've seen all of the highlights. There's much, much more that has gone into these releases. So I really urge you to read up on whatever happened. And of course, if you want to know more about the modular system, I highly recommend this Java Now Modularity book, which I think does a pretty good job of making the case for modularity and also how to use it. If you want to listen more in-depth to content around what has happened in newer versions of Java, go to this URL on Pluralsight and check it out, because there's lots of content there around that. And lastly, if you actually want to use the stuff, and well, apparently most of you can't at this moment, then come work with us, because we are actually moving in this new world of Java. We are actually using these newer JDKs in production. So I'd be happy to chat about that as well. Visit our booth and make sure that you hop on the bandwagon, at least in terms of keeping up with Java. Thanks for your time.